In the last video, we did problems and we also understood what is a conjugate and modulus, correct? Now, how do we represent a complex number on the xy axis? Okay, it's a very important point. Now, here we come across a special, not a special one, but a different type of a plane, and we name it as Argand plane. So Argand plane is that plane where you can represent a complex number. See, how do we represent a general complex number? We write it as z is equal to a plus ib, correct? Now there are two parameters here. One is the real term. So here a is the real number and b is the imaginary number, correct? So you have one real part, one imaginary part. Now we need to represent this on the plane, xy plane. Obviously we cannot take the Cartesian system, the Cartesian plane, xy plane. That is not at all possible. That's why we have another plane, that is the Argand plane. Okay. Now in this case, suppose if I have to present our value, let's say 2 plus 3i, something like this. Now what we write is, we take the normal xy axis. Okay, so let me just show it to you how it is done. Look at this graph. Now in the x-axis we write, see, along the x-axis we are going to have the real number. Okay, all real numbers we represent along the x-axis, and along the y-axis you are going to represent all the imaginary numbers. Now that you have real and imaginary numbers here, suppose say you have a value of say z is equal to 2 plus 3i or 2 plus I into 3. Now the real part is 2 and it's positive 2. So you go 2 on the right side. Okay, so this is 2. Next you have plus 3i along the positive y-axis, because y-axis is nothing but the imaginary part, isn't it? So 2 plus 3i is going to be a point somewhere over here. And this we represent it as 2, 3. Say this is z1. Okay, so z1. Fair enough. Now z2, say you have minus 3 plus I. z2 is this. Minus 3 is on the left side, so minus 3 plus I. So this is going to be minus 3 plus I, which you can represent it as minus 3, 1, and this is z2. So any coordinate system if you take, now any coordinate system generally they work on real numbers. But this Argand plane has one axis as the real axis and one more axis as the imaginary axis. And you can represent any type of a complex number in this Argand plane. Okay. Now if you remember, we had two important things, conjugate and modulus, correct? Now guys, look at the figure. The figure, you have z1 is 2, 3. That means z1 is 2 plus 3i, correct? So what you have here, this is 2 plus 3i. What is the conjugate of z1? z1 bar is equal to 2 minus 3i, isn't it? Now plot this point along this Argand plane. You have 2 in the same position, minus 3i is going to be here. So this is z1 bar, which is 2, minus 3. Correct? 2, minus 3. So we are looking at this point here. This is the point. Now same thing, suppose if you do z2 bar. z2 bar will be what? Minus 3 minus I. So minus 3 along the negative x-axis and minus I is going to be here. This is z2 bar, minus 3, minus 1. See, this is the case. Now what I want you to understand is that the conjugate of a complex number is nothing but the image of that particular point along the x-axis. See this, z1 and z1 bar. X-axis acts like a mirror and one is an object, one is an image. Same thing for z2 and z2 bar, the conjugate of z2. X-axis acts like a mirror. So conjugate of a complex number is nothing but the mirror image of the point along the x-axis. This is a very important point of how we represent and how we understand the conjugate of a complex number. So any complex number you have, if you take the if you take the image of that particular point along the x-axis, that point is going to give you the conjugate. Very, very simple to understand. Now the second parameter was modulus, correct? Now to understand modulus, again in the same figure, from point O to point Z1, say you join a line, okay? So from point O, say you are going to join this Z1, see like this. Okay, now do you see that small right angle triangle, the red color one? So that is OZ1, and then O to say this point is A, call it as A. So OAZ1, see that triangle? What is the hypotenuse of the triangle? Root of, we can calculate, isn't it? Last year, remember you had done the distance formula? Now same thing you apply, in the sense, if you take OZ1, that's gonna be, okay, see, OA is 2 and OZ1 is 3. So what is OZ1? OZ1 square is equal to 2 square plus 3 square, or OZ1 is nothing but root of 2 square plus 3 square. Don't you think this is modulus, root of A square plus B square? Now what do you understand? Modulus is nothing but the distance of the point, whatever point you have, point with the origin. That gives you the modulus of the complex number, correct? That means in general, if you have z is equal to A plus I into B, then the modulus will be root of A square plus B square. That's nothing but the distance of the point with the origin. Whatever the distance you have, that is nothing but modulus. So two important things. Conjugate is nothing but the reflection of the point along the x-axis, and modulus is the distance between the point and the origin in the Argand plane. So this Argand plane is nothing but presentation of a complex number in the axis. X-axis always real, y-axis is always imaginary. Clear? So now that we have understood what is Argand plane and how we represent it, there are different ways of expressing the same complex number. Expressing in the sense, in terms of A plus IB we have represented. There is one more way of representing that you guys will understand in the next video.